In the previous class, we have discussed long-run protection function and introduced isoquants to represent long-run protection function. Now, as we have seen, the isoquant is negatively sloped. And the slope of the isoquant shows how one input can be substituted for another, keeping output constant. We know that output is constant along an isoquant. And the analysis of the slope of the isoquant provides us information about the substitution possibility of capital for labor. So, the slope of the isoquant gives us information about the substitution possibility between capital and labor. And in the map of isoquants which we have drawn in the last class, the isoquant was negatively sloped, and it was based on the assumption that it is possible to substitute capital for labor, keeping output constant. Now, a measure of the substitution between capital and labor is given by marginal rate of technical substitution. And marginal rate of technical substitution, MRTS, L for K, in the brackets, MRTS L for K is negative of the slope of the isoquant. So, a measure of the substitution between capital and labor is marginal rate of technical substitution of L for K, and it is the negative of the slope of the isoquant. Slope of the isoquant is dk by dl. And the value of this MRTS depends on two things. One is the level of output, and the second one is it depends on the quantities of capital and labor employed. It depends on two things. One, the level of output. The second is the quantities of capital and labor inputs used. And MRTS is similar to the marginal rate of substitution. That is the negative of the slope of the indifference curve we have studied earlier. Now, to examine the shape of the isoquants, it is useful to specify MRTS L for K as equal to MPL by MP. To obtain further insight about the shape of the isoquant, we write this MRTS L for K as MPL by MBK. Let us see how it is actually derived. We have Q is a function of K and L, taking the total differential because K and L are not independent, dq is equal to dou f by dou K into dk plus dou f by dou L into dl. Dou f by dou K into dk plus dou f by dou L into dl. That is mbk into dk plus mbl into dl, and along an isoquant change in quantity dq is equal to 0. So we can write mbl into dl is equal to minus of mbk into dk, or we can write minus of dk by dl as equal to mbl by mbk. Minus of dk by dl is equal to mbl by mbk. So minus of dk by dl is equal to mbl by mbk. So more formally, minus of dk by dl dq is equal to 0 is equal to mbl by mbk is equal to mrts L for K. So as you move from so this is the, so what is MRTS? MRTS is the negative of the slope or the absolute value of the slope. So as MBL and MBK are positive because a profit maximizing firm never chooses a level of output where MBL or MBK is negative or 0, because factors of production will not be available at a 0 cost. So MBL and MBK are positive numbers, so MRTS is positive, and hence the slope of the isoquant is negative. The slope is negative, MRTS is positive because it is the ratio between MBL and MBK. This is the formal proof that MRTS L for K is equal to MBL by MBK. Now in the figure, the ridge lines K and L traces out the boundary in the isoquant map where marginal products are positive, and these ridge lines are nothing but isoclines. Ridge lines are nothing but isoclines. Ridge lines are nothing but isoclines, and isocline means equal slope. Isoclines where MRTS is either 0 or undefined for different levels of output, and MRTS is equal to 0 when MBL is equal to 0. This is a point here. MBL is 0 and MRTS is undefined where MBK is equal to 0. MRTS is undefined where MBK is equal to 0. Now you consider point C. At point C, both MRTS L for K is minus dk by dl, dq is equal to 0. So at point C in the figure, both the slope up to C negative, beyond that positive. So at C it is 0. Both slope and MRTS are 0 at point C. If you consider point F, you cannot substitute capital for labor holding output constant. You cannot substitute capital for labor holding output constant. And MBL is negative, resulting in what is known as negative MRTS, because MRTS is MBL by MBK. MBL is negative, resulting in negative MRTS. That means isoquant is positively sloped. Then you consider point D. Here, both MRTS and also slope undefined, and MBK is equal to 0. And if there is a further increase in capital, MBK become negative, as in the case of movement from point C to point F. So what we say is, in the area lying between the ridge lines, both the marginal products are positive. In the area below this lower ridge line, MBL is negative, above MBK is negative. So a profit maximizing firm will never operate in the areas above or below these two ridge lines. So ridge lines are used to segregate economic region of production from non-economic region. Just as we have defined stages of production in the short run to segregate economic region from non-economic region. And if you consider this isoquant more closely, you will also observe that isoquants are not only negatively sloped, they are convex also. Isoquants are not only negatively sloped, they are convex also. It means that MRTS decline as you move from left to right, or stated differently, the slope increases as you move from left to right. Slope is negative, slope becomes less negative. That means slope increases. Whereas MRTS is the absolute value of the slope, negative of the slope, so MRTS decreases. And this is analogous to the relation between marginal rate of substitution and strict convexity of indifference curves. Strict convexity of indifference curves we have discussed in the context of indifference curve analysis. Now, for large values of K by L, that is, if you are somewhere here, capital is very high, labor is small. So for large values of K by L, MRTS is a large positive number. Means you can substitute a large amount of capital for a given unit of L. On the other hand, if the labor is already very high, that is, you are somewhere here, labor is very high, then MRTS is low. Means that you can substitute only small amounts of capital for one more unit of labor. And in the figure, if you consider a movement from A to B, MRTS decreases due to the convex nature of isoquants. Remember this, we specify this condition only in the relevant region of production. This is not applicable below the ridge line L or above the ridge line K. Now, the assumption of convex isoquant resulting in diminishing MRTS is related to the law of diminishing marginal returns. The law of diminishing marginal returns. Let me repeat. The assumption of strictly convex isoquants with a diminishing MRTS is related to law of diminishing marginal returns. LDMR, law of diminishing marginal returns, which states that if there is an increase in the quantity of a variable input, keeping all the other inputs constant, marginal product of the variable input eventually decreases. Now we know that MRTS is equal to MBL by MBK. If you consider a movement from A to B, what you see is labor increases. That means MBL decreases. MBL decreases. And capital decreases. That means MBK increases. MBK increases. So, when you move from A to B, MRTS decreases because MBL decreases and MBK increases due to law of diminishing marginal returns. So, MRTS decreases. Numerator decreases, denominator increases, so MRTS decreases. So, this is the explanation for the convexity of isoquants. And as we know, a firm operates only in the second stage of production, and the second stage is characterized by diminishing marginal product. And in the second stage, isoquants are represented by strict convex. Isoquants are represented by strictly convex isoquants. So, in the relevant region of production, marginal product of both factors are positive but declining, and MRTS decreases. Means isoquant is convex to the origin. And this corresponds to the second stage of production. Now, so this is the explanation for what is known as convexity of isoquants. But a problem with this proof is the marginal product of an input depends not only on the level of both inputs, a change in L affects MBK and vice versa, or a change in K affects MBL and vice versa. So, not possible to derive diminishing MRTS from diminishing marginal product alone, or convexity cannot be established by using diminishing marginal product alone. This requires a little more mathematical application, and that is what we do in the next class. For the time being, remember this: isoquants are negatively sloped and isoquants are convex to the origin. Convexity resulting from law of diminishing marginal returns. Law of diminishing marginal returns, that is the first proof. And in the next class, we will give a more formal mathematical proof to the fact that MRTS decreases as you move from left to right, or that isocones are convex to the origin.